Discovery Houston.
Go ahead.
Okay, I've got a KU band stow procedure. What we're going to attempt to do is do this over Hawaii the next time that we come around. I'm going to read the procedure up. At this time, I'm not sure, it's rather lengthy. When you're ready to copy, I'll start in.
Okay, give us a second, and we'll give you a call. Okay, Mark, we're ready to copy.
Okay, Dave, basically what we need to do is we're going to turn the antenna back on, try to get it to a stow position, and then get the pins in and bring it in. First step on A1 upper, KU control command. Step 2 on A2, check digital display LAS. Step 3 on A1 upper, take KU band to auto track. Check slew rate slow. KU power on. At this point, check MCC before proceeding so that we can make sure we're locked up on TV. Next step 5 on A1U, KU control to panel. At this time, check for any antenna motion for 8 seconds. We want to see if it's stable for that length of time because that's how long it would take the pins to drive in. Step 8. Check any antenna motion for 8 seconds. If movement greater than 0.2 degrees in azimuth or elevation on A1U, KU power standby, and contact MCC. If movement less than 0.2 degrees in azimuth or elevation on R13L, KU antenna to stow. If azimuth or elevation changes greater than 3 degrees within 30 seconds after this stow, on R13L, KU antenna to ground, wait 30 seconds, then on A1U, KU power to standby. And check MCC before proceeding. At this time, we're 1 minute to TDRS East LOS. We're going to stay with IOS UHF for the next 5 minutes. All right, we're now on step 9. We're all ready to stow it at this time, so on step 9, R13L, payload bay mech power, system 1 and 2 to on. KU antenna talkback stow in 23 to 46 seconds. Step 10 on A1U, KU power off on R15 Charlie. CB, main B, KU electric open on R13L, KU antenna ground, and mech power off. And it looks like we won't have iOS. Did you get all of that? Then somebody called back and said we would have. Discovery Houston through Guam for 7 minutes. Discovery Houston through Guam for 7 minutes.
Okay, we have you, Mark. You've got quite an echo. We were cut off at iOS, and if you'd like, I'll read back what I've copied.
Okay, go ahead.
Okay, we copied first step, A1 upper, KU control the command. On A2, check digi-display to LAS. A1 upper, KU band to auto track. Slew rate slow, KU power on. And then check MCC before proceeding. On A1 upper, KU control the panel. For 8 seconds, we're going to check for antenna motion. If it's greater than 0.5 in elevation or azimuth, we'll take the KU power to standby, check with MCC. If it's less than 0.5, we'll slew to elevation minus 29.6, azimuth minus 25.1. On A1 upper, if it is less than 0.5, we'll take the KU band to manual slew, check antenna motion for 8 seconds. If movement is greater than 0.2 degrees in elevation or azimuth, we'll take the power to standby and check MCC. If it's less than 0.2 degrees on R13L, we'll take KU antenna to stow. We'll check again for elevation and azimuth movement. If it's greater than 0.3 degrees in 30 seconds after we've taken the switch to stow, we'll take the KU antenna switch to ground. Wait 30 seconds, A1 upper, KU power to standby and check MCC. If movement is less than 0.3 degrees, we'll take payload bay mech switches 1 and 2 to on, check antenna and KU antenna talkback still in 23 to 46 seconds. If it is, KU power to off. On R15 main B, KU electronics circuit breaker to open. And the KU antenna to ground. That's as much as we copied.
Okay, Dave, there's just one more step and two corrections. Payload bay mech power system 1 and 2 to off is our final step. And back up in step 6, where we talked about if movement less than 0.5 degrees, for azimuth it should be minus 125.1. And the tolerances on both elevation and azimuth are plus or minus 0.2 degrees. Down in step 8, where we talked about azimuth and elevation changes within 30 seconds, that should be 3 degrees, not 0.3, but 3 degrees.
Okay, we copy minus 125.1 in azimuth. We did have a question about that, so that confirms that. And it's plus or minus 0.2 degrees the next step, and greater than 3 degrees instead of 0.3.
Okay, read back correct.
And the last step was to take the payload bay mech switches to off.
Okay, Dave, good read back. We'd like to use camera C again. We think that's going to be the best one. And one thing back up on this explanation on this auto track and going to a panel, we suspect that one of the things that may be causing this is a power supply, and after it warms up, that could be what's causing the oscillation. So as we get into this step, we're going to be watching it very closely, and we want to move through the procedure fairly rapidly as long as we meet all of the steps.
Okay, and you want to start it over to Hawaii?
Yeah, as soon as we get locked up TV on Hawaii is where we want to start this.
Okay, we'll be ready. Houston Discovery, once again, this is not the optimum viewing angle for camera C on the KU band due to the blooming reflecting the sun off of the KU. We could probably yaw a bit to shield the camera. Looks like it wouldn't take more than a few degrees. You might consider that.
Okay, Rick, you're go to do that, and we're going to be LOS here in 1 minute. Hawaii will be at 6:18.
Okay.
Discovery Houston through Hawaii for 8 minutes.
Loud and clear. And we're ready to go on your go.
Okay, Dave, you can do steps 1, 2, and 3 down to our first go, and we're standing by to get TV here.
Okay, here it comes.
All right, we've got good downlink now.
Okay, we'll start. And we performed the first step, Houston. Houston, Discovery, you still with us?
Okay, we see you've done the first 3 steps. Dave, you can take KU control the panel and give us a mark.
3, 2, 1, mark. Okay, Houston, it looks like it's going to it has motion slightly greater than 0.5. We'd like to go to standby. We can see it rotating out the window.
Okay, tell us.
Standby and the motion stops, Houston.
Okay, Dave, you're slightly greater than 0.5. We think that's okay. Your go to slew to the angles that we gave you.
Okay, we'll go back to power on and slew to those angles.
That's correct.
Okay, Houston, we slewed to the angles and then went to manual slew. It's dithering slightly, but it looks like it's less than 0. Degrees.
Okay, Dave, your go to hit the KU antenna stow.
Okay. Okay, and by mark, we'll go to stow. 3, 2, 1, stow. Okay, Houston, it looks like it's less than 3 degrees. We'll continue with your concurrence.
We concur. Dave, proceed.
Houston, it's stowed.
Okay, Dave, we see that.
Okay, Houston, the procedure is complete.
Okay, Dave, thanks. We think we'll breathe a sigh of relief, and we can stop our EVA planning, I'm sure that you were probably doing.
Oh, okay. I think he was almost in his suit.
Okay, we're 1 minute to Hawaii. LOS will be on Hedris in 2 minutes.
Okay, see you there, and we pulled out our KU antenna overlays on the TV and confirmed it's in the envelope that says go for payload bay door closure.
Okay, great.
Houston, Discovery.
Go ahead, Pinky.
Go ahead.
Discovery Houston through Hedris East.
Very loud and clear. And Houston, Discovery, question for payloads. Is it okay to go ahead and do that PV toss initiation and ADSF sample in it now rather than waiting for an hour?
Okay, stand by, Pinky. We'll get an answer.
Okay.
Discovery Houston for Pinky.
Go ahead.
Yeah, Pinky, you can do PV toss and ADSF initiation. It looks like our current attitude will get us stars of opportunity, so we will not have to do a maneuvering IMU line.
Copy. Houston, Discovery.
Go ahead, Discovery.
Okay, I'm ready to give you a short payload report for the day if you're ready to copy.
Okay, Pinky, go ahead.
Okay, this evening we got ADSF deactivated and reactivated, and PVTOS is reactivated, running cells 2 and 6. I'll get you the times here just a sec. ADSF was started 1 day, 6 hours, 23 minutes. And PVTOS was initiated 1 day, 6 hours, 36 minutes. Dave and I did both runs of the PPE today. And Mike and I just finished taking pictures of the PCG, so we should be complete with the mid-decks for the day. Everything worked as advertised. We had MLE out all day. We tried to get a few shots with it. I don't think we got too much with it today, but we'll keep plugging along with it.
Okay, Pinky, we copied all that, and just for info, we plan on getting our pre-sleep tag up at the end of this TDRS pass, and that should be about it for the day.
Okay, we copy. You might see if you can work on some more mesoscale lightning for us tomorrow.
Okay, we'll do that. Discovery, Houston.
Go ahead, Houston.
Okay, we see stars 87 and 13 in the table. They look good, and your go to align on those.
Okay, 87 and 13. We'll put that in work. Houston, Discovery, star trackers were aligned. Would you like the numbers? Correction, the IMEs are aligned.
Okay, we copy that, Rick, and we have all the data, so we don't need it down. In the meantime, I have pre-sleep cryoconfig if you're ready to copy.
Go ahead with the cryoconfig.
Okay, cryo O2H2 tank 1 heaters A and B off. Cryo O2H2 tank 3 heaters A and B auto. And cryo O2H2 manifold valve tank 2, two of them to close, and you can expect Spec 68 message with that action.
Okay, the tank 1 heaters, all 4 off. Tank 3 heaters, all 4 auto. And the 2 O2 and H2 manifold valve number 2s, both of them to close with a message.
That's correct. Discovery, Houston.
Houston, go ahead.
Okay, I have a few notes here during pre-sleep tag up if you're ready to copy.
Houston, we're ready to copy.
Okay, first of all, on the FES, we see tank B that is under 15%. Now you can go ahead and turn the FES off. During the day, we've been unable to confirm that we're getting O2 flow through the bleed orifice, and we'd like you to confirm that the bleed orifice was installed earlier today.
Houston, Discovery, the bleed orifice has been installed on LEH 026 instead of 5 because 5 has Pinky's hookup on it, and the valve is open. At least the switch is in that position, and we think we're getting flow out of it.
Okay, copy that. We'd also like to find out the status of the cryo sensor check.
Yeah, it was good. We should have gotten that back to you this morning when we did it.
Okay, next thing, we've seen a very slow drift down of accumulator pressure in System 2. There is no problem, but we can expect that the circ pump is going to cycle on a little bit later, just for your info. For the cap tomorrow, we see everything as nominal. Your current attitude is fine. We were wondering whether or not the plus Y VV attitude that you've been in and we plan on tomorrow is good for Earth obs, or whether or not you'd like us to work on another attitude for you.
Okay, Houston. The best attitude is tail to the velocity vector for Earth obs, just because you can see things coming out the back window sooner. Next, after that, then our cap attitude of nose into the velocity vector is next best. We can work with the attitude we're in if that's what y'all prefer.
Okay, thanks, Dick. We'll let the planning shift work on that one tonight and see if we can't come up with trade-off between the two. And that's about all I have. We're going to update the state vector next rev, and IMUs, everything else look good right now. Do you have anything for us?
No, Mark, I guess we don't have anything really for you. We do have the teleprinter message. We're reviewing it at this time, and we'll be prepared to talk about the subject that came up tomorrow. And I guess we're kind of wishing that we would have done what we talked about, which was put some beer down on whether or not accumulator 2 is going to leak.
Okay, we copy that. And just checking, we did get the FES off, is that right?
That's permanent FES off.
Okay, copy. Well, we had a good day down here. We had a lot of work to keep us busy, so we have happy campers here too.
Okay, Mark, and we'll talk to y'all either before we go to sleep or folks tomorrow morning. Thanks a lot.
Okay, and right now we don't have anything else, so unless something comes up, this will probably be the last call.
Last call, that sounds familiar. I'm not quite sure where.
Discovery, Houston.
Go ahead.
I guess you woke up with that message. You don't have to worry about it. It's just the reservoir pressure decaying due to some thermal effects. The system's is good, and you can go back to sleep.
Okay. Thanks a lot. Good night.
Good night.
Don't stop. Good morning.
Discovery, Houston. Good morning. How are you doing?
Great tunes. You're loud and clear.
Roger that. We're about 1 minute, 20 seconds till LOS Tidris will speak to you at Canberra in about 24 minutes. We don't have anything for you right now.
Okay, we'll be up and about by then.
And Discovery, your morning mail will be delivered next Tidris pass.
Okay, we won't go out to the box yet.
Discovery, Houston, with you through Canberra for about 2.5 minutes.
You're loud and clear.
Roger that. And a quick note for you before we go LOS. No supply water dump today, and when we get AOS Tidris so we can watch and at your convenience, we'd like you to take the FES controller primary B to on, and stay in that config until the supply tanks Charlie and Delta reach a quantity of 55%. And that's the topping evaporator I forgot to mention.
Okay, copy. When we're AOS next, topping and primary A on, taking C and D, say again the percent.
Okay, primary B to on topping and the percent of 55%.
55%. 25% primary beam on. Okay.
And Discovery Houston, 30 seconds to LOS Canberra. Pick you up in about 16 minutes on Tidris East. Discovery Houston, the Orbit 1 team is with you through Tidris East. Good morning.
Roger, Houston, loud and clear.
And you're loud and clear also, and I've got one quick flight note for you on page 5-10 of the Orbit Ops checklist.
Okay, stand by one. Go ahead on page 510, David.
Okay, the Eclipse redundant component checkout is an easy cap activity. What we would like you to do when you turn the humidity separator A on is leave that one on. Do not go back to the humidity separator B. The reason for that is that we were not seeing the quantities in the wastewater tank as high as we expected. We think there might be a possible degradation in the humidity separator B. So leave pump sep A on, please.
Copy, leave A on. Houston, if you're ready, we'll turn on FES B.
Discovery, we are ready for that.
Okay, I'll do that, and then we're going to go down and eat some breakfast.
Copy that.
Houston, Discovery.
Discovery Houston, go ahead.
Roger, the cryo O2 tank heater sensor check was good this morning.
Okay, we copy that. Thank you. Discovery Houston, 2 minutes to Tidris East LOS. We'll pick you up at Yargady at 18 plus 53.
Roger, talk to you at Yargady.
Discovery Houston through Yargady UHF for 9 minutes. Discovery Houston through Yargady UHF for about 6 more minutes. Discovery Houston, 1 minute to Yargady LOS. We'll see you at Canberra another minute after that. Discovery Houston through Canberra for 5.5 minutes.
Roger, Houston, just to bring you up to date on some of the easy cap items we've done. We've got the RCS regulator reconfig complete. The heater reconfig was completed at 1 day, 18 hours and 40 minutes. And we've got the Eclipse redundant component checkout completed, as well as we're reconfigured to PCS System 2.
Okay, Dick, we copy all that. Discovery Houston, 1 minute to Canberra LOS. We'll see you Tidris East next at 19 plus 24.
See you then.
Okay, now one other reminder too, I'd like you to check to see that your UHF is enabled. We were trying to pick you up over Yargady and we're unable to. Discovery Houston back through Tidris East.
Yes, loud and clear.
And you're loud and clear also.
And Houston, Colonel Covey's completed the minus X coas cal, correction, plus X coas cal, and the data is 1.97 delta bias, and updated at 1:19:23:25.
Okay, Rick, we copy that. Thank you.
Houston, Discovery.
Discovery Houston, go ahead.
Okay, when you tried to call us over Yargany, we still had the air-to-air deselected on the upstairs speaker from the sweep configuration, so that's why we couldn't hear you.
Okay, Dave, we copy that.
And it is
Good
selected now.
And Discovery, if you've got the IMU data, we'll be happy to take that now, too.
Okay, wait one. Okay, here comes the IME data.
We're ready?
Minus Y37, minus Z16, angle error 0.01. I'll read across delta X's. Minus decimal 06, plus decimal 04, minus decimal 08. Delta Y's minus decimal 01, minus decimal 04, minus decimal 03. The Z's plus decimal 06, plus decimal 06, plus decimal 01. Execute time 1 day, 19 hours, 13 minutes, and 5 seconds.
And Rick, we copy that. Thank you.
Houston, Discovery.
Discovery Houston, go ahead.
And sample 6, 1 day, 15 hours, 57 minutes, and 40 seconds. And those are according to the clock that's in the PV toss, and it's about a minute off of the MET we've got on board, and I don't plan on resetting unless you want me to.
And Pinky will ask. Discovery Houston, for Pinky, you do not need to reset the clock for PV toss.
Okay, we copy, thanks.
Discovery Houston.
Go ahead, David.
Yeah, I've just got a question about your coas. Your delta bias seemed fairly large to us. Is your coas still mounted?
Negative.
Okay, we just wanted to check the mounting of it, but I guess we can't do that right now. Thank you.
Houston, Discovery.
Discovery Houston, go ahead.
Roger, regarding the coas cal, putting the adapter plate to mount the coas over the CDR's HUD, it turned out that the nut that the screws into to hold it against the panel apparently had come off, so we could not tighten the screw down against the panel. However, the 3 pins, the guide pins that hold the adapter plate into the overhead panel, seemed to be snug enough. We snugged it in and then taped the adapter plate in, and it seemed to us that there was virtually no movement of the coas. When Dick did the cal, we did several delta biases, got consistent readings, and then we did the updates and several checks and got consistent readings. So we think we got a good cal, and we think we could use it for alignment if necessary, even though we did not have the plate screwed on tight. It was on firmly.
Okay, Rick, we copy that, and we appreciate your words.
Roger.
Discovery Houston, just a reminder, we'd like you to take your star trackers to track, please.
Roger.
Discovery Houston, we're handing over from TDRS East to iOS UHF. We'll have you through iOS for about another 4 minutes or so. Excuse me, about another 8 minutes.
Indycom, Sunnyvale.com on the UHF.
Discovery Houston, we've got you through Indian Ocean now for about another 6.5 minutes.
Roger, Houston.
Discovery Houston, 2 minutes to LOS iOS. We'll see you at Yargady at 20 plus 29.
Roger, Houston.
Discovery Houston, UHF Yargady for 8 minutes.
Hello, Houston. We're all set up for LRAD and are just about there.
We copy.
Discovery, LRAD's clicking away, and we're sure enjoying seeing the lights of Western Australia and the Southern Cross.
Copy that, Rick. Discovery Houston, 30 seconds to Yargady LOS. We should pick you back up Canberra shortly at 20 plus 38. Discovery Houston through Canberra for 5 minutes.
Loud and clear.
And you're loud and clear also. Discovery Houston, 30 seconds to LOS Canberra. We'll see you TDRS at 21:01.
See you there.
Discovery Houston through TDRS East.
Loud and clear, Houston.
And you're loud and clear also. Discovery Houston.
Roger.
Yeah, Rick, your cabin N2 message appears to be coincident with the switchover from the O2 to the N2 cycle. We see the N2 coming down at this time. There's no action required.
Okay, and that was coincident also with exercising the WCS.
Okay, thank you. Discovery Houston with a flight note for you.
Go ahead, David.
Okay, we're ready to terminate the supply water dump. Over on L1, we'd like you to take FES Pri B to off. And just for your information, it looks to us on the ground as though your primary A and B controllers both look pretty good, and your topping evaporator was looking pretty good today, too. Separately, we would like you to, over on L12L, take your supply water crossover valve to open. Check the talkback open. And that's to help balance the tanks B, C, and D, the levels in tanks B, C, and D. Over.
Okay, we've terminated the dump and we've got the crossover valve open.
Okay, thanks, Pinky. Discovery Houston, we're about a minute and a half to TDRS East LOS. We'll still have you through iOS for another 3.5 minutes. After that, we'll see you at Yargady at 22 plus 05.
Okay, we copy. We'll see you then. And we're just waiting for sunset in LRAD.
Okay. Discovery Houston through Yargady UHF for 8 minutes.
Okay, you're loud and clear.
And you're loud and clear.
Find the mic, is it? we're getting into orbit in terms of Mach, or a ratio of the orbiter's velocity relative to the speed of sound, and we're up actually, is that 5 minutes from your first 30-second cycle?
Negative, Rick. That's from the end of the cycling.
Okay, after we've done the cycling.
Roger. So from the last time you turn the secondary on and leave it on.
Okay, thanks.
Discovery Houston, I've got a flight note for you when you're ready to copy about the ohms gimbal checks.
Go ahead.
Roger, Rick. We'd like you to move up the time that you perform the entry ohms gimbal check. We would like it performed at TIG minus 1 hour, 53 minutes, and once you're in Ops 3. And just a reminder to not do any checks on the left ohms secondary.
Okay, we'll do the ohms gimbal checks minus 1 hour, 53 minutes in Ops 3, but we will keep the left in secondary, primary.
Roger, and the reason we're doing this is we just want to cover ourselves in case the left primary should have some problems.
Roger.
Discovery Houston.
Roger.
Rick, you have a go for payload bay door closing.
Roger, go.
Discovery Houston.
Roger.
Rick, we saw good fast operations, no indications of ice anywhere.
Outstanding.
Amen to that.
Houston, confirm that you've sent us our last message now. On the telephone.
That's affirmative.
Okay, we're going to take that down.
Roger, we copy. Discovery Houston, we've got about 2 minutes left on TDRS, but we should have continuous comm through Indy for 2 additional minutes.
Roger.
Discovery Houston, we're 1 minute to Indy LOS. Pick you up at Yargity at MET 2055.
Roger.
Discovery Houston, I'm with you at Yargity for 8.5 minutes.
Loud and clear, Houston.
Loud and clear also, Dave. Discovery Houston, we're about to lose you at Yargity in about a minute. We'll have a 30-second drop and then get you at Canberra for another 5. Discovery Houston, we're with you at Canberra now for the next 4.5 minutes.
Roger, and you do have about a 1 second echo.
Discovery Houston, 2 minutes to Canberra LOS. We'll get you at TDRS at 21:29 MET.
Roger, Houston, we'll talk to you through TDRS, and we've got the stars in, doing the align now. We'll go ahead and maneuver to the verification attitude and give you results when I get to TDRS.
Roger, we copy and concur with that. See you there. Discovery Houston with you at TDRS.
Loud and clear. And payload bay door operation, we're nominal.
Outstanding. Copy nominal.
Also, I have the IMU line pad if you would like it.
Discovery, no read down is required. We have all the data. Thank you.
Roger, and the verification was good.
We agree with that. And Discovery, Houston, I have your del pad and maneuver pad when you're ready.
Okay, wait, what? Houston Discovery, just one little thing on the payload bay door closure. On the starboard door, the forward ready for latch talkbacks, we are ready for latch micro switches. We only had 2 of 3. Everything else was nominal, and the trajectory looked real nominal as well.
That's some good eyes there, Dave. We copy and concur.
Hey, Houston, we're ready to copy the pads.
Roger, Discovery. I'll come up with your maneuver pad, if that's okay.
We're ready.
Okay. Ohms, both. TV roll, 180. Trim loads, pitch, 0.0. Left yaw, negative 5.7.
Houston, you cut out.
Trim loads, pitch, 0.0.
Break. Houston, you cut out. Start again after TV roll 180.
Roger, Rick. Trim loads, pitch, 0.0. Left yaw, negative 5.7. Right yaw, plus 5.7. Weight, 202,811. TIG, 0. Repeating TIG, 03 slant 23 colon 57 colon 45.0. Peg 4, C1. C1 is 1-4. Again, C1 14839. C2 negative 0.5963. Height 0.65.832. 130.469. Propellant, all balls. Attitude.
Break. Blaine, you cut out after C1. Would you start with C2, please?
Roger, Rick. Stand by 1. And Discovery, Houston, I'm ready to go, starting with C2. Discovery, Houston, let's postpone this for 6 minutes. There's some ground comm checkouts going on, and we'll postpone until we can get good continuous comm.
Roger.
Discovery, Houston, you are go for Ops 3.
Roger. Houston, if you pass us on the orbit maneuver, burn, attitude, we'll enter that.
Okay. Roll 061. Pitch 180. Yaw 315.
Pitch 180, yaw 315.
It's good readback. And Discovery, Houston, back on TDRS with you.
Loud and clear.
All right, Rick, we have you loud and clear now, and we're not expecting any more comm checks or dropouts, so I can begin the maneuver pad again with the Peg 4 targets, I think is where we dropped off.
We already have Charlie 1. Give us Charlie 2 and subsequent.
Okay, Charlie 2, negative 0.5963. Height 0.65.832. 130.469. Propellant, all balls. Attitude you have, REI 4100. Time of free fall, 29er, colon, 03. Delta V total, 325, decimal 3. TGO, 02, colon, 48. Vigo X, plus 312, decimal 908. Y, all balls. Z, plus 088, decimal 89er. HA, 167. HP, plus 008. Read back.
Okay, read back on the deorbit maneuver pad is ohms both. TV roll 180. Pitch 0.0, minus 5.7, plus 5.7, 202.811, 03 slant 23 colon 57 colon 45.0, 14839 minus 0.5963, 065.832, 130.469, all balls. Attitude 061 180 315 4100 29 colon 03 325.3 02 colon 48 plus 312.98 all balls plus 088.89 167 plus 008 over.
That's a good read back, Covey, and when you're ready to copy, I'll give you the Del pad.
Roger, Houston, go with the Del pad.
Roger, TIG slip, 5 colon 00. 2 colon 00. Left ohms HP, 136. Right ohms, 136. Safe HP, 80. Aft quantity 1, 9er 0. Aft HP, 1 9er. Primary HP, 40. Backup HP, 45. Aft quantity 2, 37. Forward RCS dump, aux, 00. XCG at EI, 1098.0. At Mach 3, 1096.2. YCG, plus 0.1. EI minus 5 attitude. Roll 030. Pitch 260. Yaw 066. Pre-bank left. All balls. Yargity AOS EI minus 22. Yargity LOS EI minus 15. Altimeter 29er decimal 908. Closed loop guidance 00 colon 34 colon 11. First reversal 15850. Landing site 15. Left overhead 249. Edwards 17. TACAN 111 X-ray. Aim point nominal. Speed brake 15%. Winds 50,000. 300 slant 10. 40,000. 250 slant 20. 30,000. 250 slant 15. 20,000. 180 slant 15. 7,000. 150 slant 10. Surface winds 240 at 7. APU start 1, then 2. Read back, please.
404537. Aux to 0, 1098.0, 1096.2, plus 0.1, 030, 260, 066, left all balls, Yargity at EI minus 22, Yargity at EI minus 15, 29.98, 00:34:11, 15850, 15, left overhead, 249, Eddie 17, 111 X-ray, nominal aim point, 15%, winds 300 at 10, 250 at 20, 250 at 15, 180 at 15, 150 at 10, surface 240 at 7, APUs 1, then 2, over.
That's a good read back, Cubby. And Discovery, I have your deorbit burn flight rules when you're ready to copy.
Go ahead.
Okay, the column labeled 1 day no, you can line down that one. The only changes are under Eclipse, a right-in H2 tank or manifold leak. Put X's in both yes columns. Under ohms, delete the line, both ohms engine fail. That's all the changes.
Okay, under ECLS, H2 tank, manifold leak, X's in both one orbit, 1 day delay, and delete the both ohms engine fail, and delete the 1 day no delay column.
That's a good readback, Rick.
Houston, ops transition in progress.
Roger, we copy, Rick. Discovery, Houston, we're uplinking targets to the BFS.
Roger. Houston, if you're happy, I'll do the gimbal checks now.
We're ready and standing by, Rick.
Houston, Discovery, we're going to be into the entry switch list and verification a little bit early unless you have some objections.
Roger, Rick. We're still checking around the room, but for now, we would like you to reload the targets in the past, please.
Yeah, we're doing that.
And Discovery, Houston, I have one flight note concerning your RAD activation on entry.
Go ahead.
What's happening here is we're looking at some older procedures that we used to do for RAD cycling. But when you bypass at 12K, if the bypass valve talkback goes to bypass, after you have gotten RAD flow, we would like you to cycle the affected loop RAD controller off and auto B. And that's due to the unique cold soak situation we have, which might cause a low temp bypass.
Roger, we've got that.
Discovery, Houston, you have a go to enter the switch verification early.
Roger. Houston, Discovery.
Go ahead, Discovery.
Blaine, we ran into a little problem with the cautioning and warning reset. The MPS helium reg parameters are causing continuous caution and warnings at this, or alarms at this time, so we're going to delay doing that until we get ready to pressurize the system.
Roger, Dick, we concur with that. Discovery Houston, your gimbal checked. Looked fine to us.
Roger.
Discovery Houston, we're 2 minutes to Tidris LOS. We'll pick you up at Yargady at 2231.
Okay, Blaine, we'll see you then.
Roger. Discovery Houston with you at Yargady for 8 minutes.
Clear, Houston, and we're all getting into our suits.
We copy. And Discovery Houston, we've got a minute and a half to Yargady LOS, and we'll pick you up at Tidris at 21. Stand by. Pick you up at Tidris 2305.
See you there.
And Discovery Houston, we'll pick you up at Hawaii at 2257.
Okay.
Discovery Houston with you at Hawaii for 8 minutes.
Roger, loud and clear. We're all suited up, ready to come home.
Fantastic. Discovery Houston, we're with you on Tidris now.
Loud and clear.
You're the same. Discovery Houston, I've got a small flight note here I hate to bother you with, but it pertains to the SSME hide repress on page 3-34 of the entry checklist. When you get a chance to look at it, let me know, please.
Okay, Houston, go ahead.
All right, it's a real small change. The last line on R2 about the MPS helium isols A, center and right, we want to delete that line. We do not want to close those. The reason is if we close them, the bleed down will be pretty rapid and it would probably give you some nuisance alarms during entry, and we just don't want to do that. So delete the last line of the SSME hide repress.
Okay, Blaine, I got that. I'll delete that closing the center and right helium ISO A's.
Roger.
And Houston, we're looking at our landing site right now. Looks pretty good.
It's a beautiful day down there and lots of folks waiting to see you land. And Discovery, just for your info, Dan and the STA flew a first approach that looks great.
Easy for him to say. And Houston, Discovery, if you're ready for it, I'll do the APU pre-start.
We're ready and watching, Dick. Go ahead.
Houston, got 3 great talkbacks. I'm ready to take the fuel tank valves back to close if you concur.
Discovery, we concur. Discovery Houston,
Roger.
we would like a reload of the targets, please. We just shipped up a new update to you.
Okay, in order.
Discovery Houston, go for deorbit burn.
Roger.
Discovery Houston.
Roger.
If you would you confirm the pneumatic helium ISO valve closed, please?
Roger, it's closed.
Thank you.
Houston, Discovery.
Go ahead, Discovery.
Roger, just want to verify with y'all that the pressure oscillations we're seeing and low press on APU-1 are okay. Hydraulic system.
That's a firm that looks good.
Okay. Houston, Discovery.
Discovery Houston with you at Yargity. Go ahead.
Roger, the burn was good, no residuals. However, at ignition, you may have seen the FES evap out temp went high. We let it ride high till the burn was complete. We've executed the pocket checklist procedure to the point where the secondary is on, high load enabled, and it is controlling at 60 degrees.
We copy. Thank you.
And Houston, I imagine you saw it, but let me correct what I said. It was not at ignition. It was well into the burn that we got the alarm.
Roger, we copy, Rick. Discovery Houston.
Roger.
Just to confirm, Rick, you do not need to perform step 4 in the pocket checklist.
We'll look at that.
And that was for that evap out T message. You do not need to perform step 4.
Okay, we'll reconfigure back to the nominal.
Roger, we copy.
You want me to get those topping heaters back on?
Standby 1. And Discovery, if those heaters are off already, you can leave them off.
Okay, that's the configuration.
Discovery Houston, we're 1 minute to LOS Yargity, and we'll see you when you come out of blackout. Discovery Houston with you at Hawaii. How do you read?
Houston, I can hear you trying to call, but you're broken.
Discovery Houston with you at Vandenberg.
Nice to hear your voice, loud and clear.
Same to you, loud and clear, Rick. Discovery Houston, Energy, Ground Track, and Nav are go.
Roger.
Discovery Houston.
Go ahead.
Roger, Rick, we'd like you to put your RHC panel trim switch to inhibit.
Okay, I flipped that by mistake.
Discovery Houston, take tack hands.
Roger, tack in.
Discovery Houston, request a state vector transfer to the BFS.
Good work.
Discovery Houston, take air data to GNC only.
GNC only, we'll go.
Discovery Houston, take air data to nav.
Roger.
Discovery Houston, recommend vector transfer to the BFS.
Look up. And you had a loud squeal at the beginning of that transmission.
Roger, copy.
Okay, that sounds good.
Discovery Houston, on center line, on glide slope. Winds are calm. Looks real pretty.
Roger. Wheel stop.
Roger, wheel stop, Discovery. Welcome back. A great ending to the new beginning.
Thanks a lot.
Discovery Houston.
Convoy, this is Discovery. How do you read? Thank you very much, and I read you loud and clear.
Discovery Houston, 1 Delta.
Roger.
We'd like the secondary controller to off, please.
Roger, understand the fast secondary controller off. Coming off.
Houston, ET umbilical doors are coming open.
Copy umbilical doors.
Houston, Discovery. Disregard. Houston, Discovery, Ohms, RCS, and side hatch safing are complete.
We copy Ohms RCS and side hatch safing complete.
Houston, Discovery, we're going to do the hydraulic load test.
Discovery Houston, that is affirmative.
Okay, I'm ready to proceed with that if y'all are.
Discovery Houston, you have a go for that hydraulic load test.
Roger. Houston, hydraulic load test is complete.
Roger, we copied. Discovery Houston, you have a go for the Ops 9 transition.
Roger. Stop my mic out.
Houston, Discovery, SSME repositioning is complete, ready for APU shutdown.
And Discovery Houston, we concur you have a go for APU shutdown.
Roger.
Discovery Houston, you have a go for extended power up.
Roger, go for extended power up.
Houston, APU hydraulic shutdown is complete.
Roger, we copy. Discovery Houston, we'd like you to select ammonia, Pri-A GPC.
Roger, Pri-A GPC now. Correction, ammonia, it's there.
Roger.
Houston, Discovery is ready for vent door purge positioning.
Discovery Houston, we would like water loop 1 on, please.
Go, water loop 1.
Discovery Houston for copy.
Go ahead.
Roger, we would like all 6 helium isols to close, GPC, and the pneumatic helium isols to GPC.
Roger, it's in work.
Roy Tarp, call
3233. Roy Carp, 3233.
Discovery Houston.
Go ahead.
We'd like a couple switch throws on panel A7 if somebody's available to do that, please.
Okay, Blaine, say again the panel.
That's panel A7, and I think it's Lima, the lower portion.
Okay, go ahead.
We would like the FDM, that's Fox Delta Mike, control switch to auto cal. Momentarily hold it a couple seconds and then release it.
Okay, that's complete.
All right, and right below it, the PCM wideband ASIP, that's A Alpha Charlie India Papa, switch to off.
Okay, the wideband ASIP PCM to off. Is that correct?
That's affirmative.
Okay, that's off.
And Discovery, one last switch. We'd like the BFS taken to standby, please.
BFS to standby, roger. That's complete. Houston, Discovery radio check.
And Discovery Houston, we have you loud with a slight echo.
Roger, I got you loud and clear. And the crew's coming off comm, the change out crew's up.
Well, Roger, we just want to send you our congratulations. You made us all extremely proud, and you can look forward to a great party at your arrival in Houston. A lot of folks are waiting to welcome you back.
Roger, we'll pass it along.
This is Mission Control Houston. That sound you hear is the clapping of all the flight controllers from the 3 flight control teams that have supported this mission. They have just been told that the people from the ECOM discipline who worked with a flash evaporator problem throughout the flight have all been awarded the honor of being selected as the most valuable controllers for this flight. That's a mission control tradition that goes back many years, always follows the conclusion of the mission, and they will shortly be hanging the STS-26 mission plaque in the control room. In the Mission Control Center right now in Flight Control Room 1, all of the back room, front room operators from all of the shifts that supported this flight have all gathered in this room. There's a lot of shaking of hands, slapping of backs, applause. And that applause is for Steve McClendon, the Orbit 1 ECOM, who led this team on the Orbit 1 shift and has been selected to hang the plaque here in Mission Control. When Discovery touched down at Edwards Air Force Base, of course, the jobs of the flight controllers here was to continue to monitor their consoles and watch all data systems aboard Discovery. Their job doesn't end until the crew leaves the ship, and so the celebration in Mission Control doesn't begin until that time, and it has begun now. There's a no smoking rule that's been enforced at the Johnson Space Center for about a year now in public places, but Ascent Entry Flight Director Gary Cohen has said Asset Entry Flight Director Gary Cohen said, "Smoke 'em if you got 'em," and that was followed by Steve McClendon hanging the plaque in Mission Control. That was the cause for the that last applause. The control team now milling about at their consoles, happy at the successful conclusion to this mission. And after a mission elapsed time of 4 days, 1 hour, and some minutes, this is Mission Control Houston signing off for the flight of STS-26.